Hi all, welcome back to another lecture of DBMS, and in this lecture we will learn about relational models, structure of relational model. Along with that we will also see some parameters like domain, attribute, relations, degree, cardinality and relation instance. Then we will see the characteristics of relations and then we will map the ER diagram to the relational schema. So this video is again going to be very much important. So stay tuned and let's begin with the today's session with relational models. So in relational model, the data and relationships are represented by collection of interrelated tables. So in the relational model, it basically shows a structure where the tables are related to each other in the row column forms, right? Each table is a group of column and rows where column represents attribute at the parameter and row represents the records. Row represents the entry of any person or it's an entity of instance, we can say. That is called record. So attribute are nothing but the columns and have properties or fields of that entity. So transaction table, transaction ID, customer ID, product ID and purchase date are the parameters or attributes for the transaction table. Define the characteristics of data stored in the each tuple, and it also defines what type of data structure that particular attribute is going to store. Next, tuple and attributes. So tuple and attributes together form a table. Tuple, this row and attribute column together form a table which is structured collection of data in a relational model. So tuples are nothing but rows, you can say here, and attributes are nothing but columns. So tuples are individual records in database that represent a single instance. So here one tuple means one row and it actually shows that one entry in the transaction table with transaction ID, customer ID, purchase ID and purchase date. Similarly, this one single attribute is nothing but the column or the parameter which represents one property for transaction table, and together they create the relational model. Now next is domain, attribute and relations. So domain is nothing but it is a set of values that are permitted for an attribute in a table. So set of values basically for customer ID, if we are saying that it can be an integer itself, so that is called domain. So it is a set of values permitted for an attribute in a table. So here age can be only a positive number. Aadhaar card can be integer of 12 digits. So these are domain. Basically we are giving the permission or permitted value to be used for the particular attribute. Attribute we already know. It's a column in the relational model. It's a column basically to define the property, one type of property for the entity. So each column in a table and each attribute are the properties which define a relationship. Tuple is nothing but a single entry or instance or a single row in a entity. Relations are in the table format. Relations means row cross column, right? So together they form a relation. Relations are in the table format and stored along with its entities. A relation exists between records and columns. So records and columns, relation exists when records and columns together combine and form basically relations. So this is all about domain, attribute and relation and what exactly each parameter defines. Next is degree, cardinality, relation instance. So degree is basically the number of attributes of its relationship schema. So here if you can see there are 4 attributes allowed or allocated for one customer table. So we can say it is a degree of 4. So a relation of degree 4 means that it stores information about 4 customers which would contain 4 attributes describing each customer. So the number of rows can be multiple, but here in this case it is 4, it can be 5 also. But degree defines by the number of columns or number of attributes you have used in that particular entity. So cardinality is the total number of rows present in the table, and a relational instance is something different. It is a finite set of types at a given time. So at a particular instance means at a particular or at a given time. So at a given time, whatever the data inside the table you can see is called the relational instance. So it is a finite set of types at a given time. The current relation state reflects only the valid types that present a particular state of the real world. So inside that table, inside the relation, there can be multiple datas, but every millisecond you are doing the manipulation, like you are deleting it, deleting the record, you might be updating or modifying, you might be inserting new records, right? But at a particular instant of time, when you are seeing that data, that relation at a particular time, that will be called relational instance. So these are all about the definitions of those parameters like degree, cardinality, and relation instance. I hope you understood. Now let's move on to the characteristics of relational DBMS, means database management system. So what are the characteristics of relation? First is ordering of tuples. So tuple is nothing but, we know that it row in a table. So it is tuples in relation have no specific order. So the data, the row which we are inserting in the table do not have a specific order. We can insert the rows in any order, right? So it allows multiple rearrangements based on attributes like name or age. Second is order of attributes. So order of attributes means order of columns. Again, it is also insignificant and each attribute is identified by its name regardless of its cues. So even if you have put your name column first and age column second and Aadhaar number column last, it doesn't mean that we won't be able to recognize the record. It's not like that. We don't recognize the record on the basis of what has been inserted first, but we rather go for the column or attribute name, right? So again, either for rows or either for column, we don't we don't consider or we don't give the value of arrangement. It can be arranged in any order, in any manner, and that is a characteristics of the relational database. Next is values in tuple. So tuple is basically row. So in a row, we can keep integer value, character value, string value, and even the null value, right? So all the values are atomic. Null represents unknown or inapplicable values. So in case of null, if we are giving some cell value as null, it means we don't know it. So it's an unknown value or inapplicable value within the tuple. So ordering of tuple, order of attribute, values in a tuple, and interpretation of a relationships are the characteristics of relational database. Where interpretation of relation means a relation schema act as a declaration with each tuple representing specific fact or instance of the schema. So a relational schema is the structure where each tuple, each row represents the specific fact or instance. So each row specifies the instance of that schema. So all these characteristics are very important for relational database management system. Now let's see the database and relational database and what is the difference between these two. Database is nothing but it's a structured collection of data, whereas relational database is also structured collection, but we store it in the form of table, and also we specify the relationship between that tables. Data can be stored in various formats in the database like text, binary, but data in the relational database can only be stored in tabular form using rows and columns. Database relationship between data are not enforced. That is why it's database and not relational database. But adding this relationship property in the relational database makes it adding the relationship properties in the database makes it relational database. So relationship between tables are defined using foreign keys. How? So basically, let's suppose we have person table, and in this you have Aadhaar ID as primary key. Okay, primary key, we know that primary key uniquely identifies the instance and it cannot be duplicate, right? Or it cannot be null also. So we have a person table, and another we have, let's suppose, orders table. Orders table. So in orders table, to make them related to each other, we have given the Aadhaar number attribute to it also. But in case of order, it will be a foreign key. And we use this foreign key only to make the relation and to find the relation between person table and order table. So that is what they find, and they make the relationship between tables using the foreign keys. But in database, there are no such relationship exist between the entities. So that was the basic difference between database and the relational database. Now let's see the advantages and disadvantages of relational database. If we'll talk about advantage, obviously it ensures the data is accurate and consistent across the database using the constraints. As we are also using the table and row format, so basically we are making the readability more simple, and also we have provided the security measures like authentication, user roles, access, and privilege. It also ensures that transactions are processed reliably. So it is very important in case of transactions, because relational database gives the ACID properties which we have already learned: atomicity, consistency, isolation, and durability. So basically that makes the transaction to be more secure, and it also provides the authentication for the only authorized user to access, and it ensures the data should be accurate and consistent. But along with these advantages in the relational database, we also have some disadvantages. What are those? Let's see. The relational model is complex, obviously, and designing large system requires extensive planning and setup. So when we talk about the large volume of data, then we have to arrange in a 2D plane, right? The rows and columns, and maintaining that can be a complex task when there is a huge data. For a very large data set or high throughput applications, relational database can be slower as well due to overhead of managing relationships, constraints, and ACID properties. As we know that to maintain the, and to remove the redundancy, we have some normalization techniques which divides a higher level of entity into smaller levels, and maintaining those when we are talking about maintaining the huge data, that can be complex, and that might bring the system to be work as slower. Along with that, as it maintains the ACID properties, all the required checks for the authentication or for reliable transaction, that will again going to consume more time, and that is also the disadvantage of the relational database. Next is commercial. So obviously, for a commercial RDBMS system, example Oracle or SQL, can be expensive and require license fees and specialized hardware. So to maintain that relational database, we require systems like Oracle and SQL Server, and that can be expensive. And to maintain that, we need some more specified or specific hardware that can add the cost for sure. So these are the disadvantage. Maintaining can be complex and going to consume more time, because it gives you the authentication and ACID properties for reliable transactions. So it is going to take a lot more time compared to the DBMS. But and along with that, it also brings the commercial cost with it. So these are the basic advantages and disadvantages of relational database management system. Now let's see how we map the ER diagram to the relational schema. So ER model is nothing but the conceptual or logical structure of database, right? While relational model is the physical representation. So this is the ER diagram which we have shown here. Person table, a passport table. For every person there can be one passport, right? And person table has one attribute called person ID, and passport has one attribute called passport number, right? So this is nothing but the ER model, the logical representation. Here the actual data does not exist. But when we talk about relational model, we say that the actual data and the actual table consist of these attributes and entities. So here it is a physical representation that can be directly implemented using the RDBMS system like Oracle. So with this structural or logical implementation, we can implement this ER model thing inside the physical device, that is a relational database model, with the help of Oracle or MySQL. So here there will be one person table, and that will have person ID as attribute. Another we have passport table and have passport number as attribute. So let's suppose passport ID, person ID 1 to 12, and passport number can be 2, 3, 4. Similarly, 1, 5, 7, 8, 9, 24, 8, 4, 6. So this is how the relational database model looks like, and this is how the actual ER diagrams looks like. Okay. And with the help of Oracle or MySQL server, we can convert this logical implementation into the physical implementation. And that is how we map the ER diagram to the relational model. That is all about the whole lecture. I hope you learned and understood each and every topic. Now let's meet in another lecture. Till then, keep learning. Take care of yourself and your family too.